Thanks very much for the introduction. Hello, everybody. Really pleased that so many can join to listen to this talk on the journey we've taken in Oman. Just flip through slides. Right. So who are we? So 2019, we decided to set up Knights Bay Limited to look at different operations, something to get into after we'd left our previous life building an antimony smelter in Oman. And we found that ultimately underexplored, lots of sunshine, and we went out looking for something to keep us busy. And in 2020, just as COVID hit, we were introduced to what we thought was a conventional nickel-laterite within the sequence of rocks in Oman. Turns out it was much more a sedimentary formation with very, very consistent grades vertically and horizontally, and a very large area and quite a reasonable thickness of material, and we'll go through all of that within the presentation. We then, once we had discussions with the ministry about looking at this particular deposit, we set up Knights Bay in 2021 to make a unsolicited proposal to the government to be allowed to investigate this property as they were reconfiguring their mining regulations and mining law, which wasn't resolved until 2023. And finally, we registered Knights Bay Orix as a holding company for Knights Bay Mining, which makes the operation of Knights Bay Mining much easier, because in Oman, even if somebody holds one share in the company, they must be present for all critical changes to shareholding. So it's not a very easy administration unless it's a sort of one-man type show. So what is our purpose? We saw this deposit, and after a 3.5-year journey, we were awarded a 1,500 square kilometer mineral block, number 21 in northeastern Oman. And it is a huge area, and the deposit on it is very big, and there's some other interesting stuff that is there as well. So we had left Oman officially in 2019 after we'd sort of saw what we wanted to do, and we obviously had the interaction of COVID with everything we were doing, and we moved back in 2023 after we were awarded a royal decree, which is effectively an act of parliament that gives us the right to operate as a mining company anywhere within this mineral block to explore and develop all designated minerals, which is pretty much everything outside of limestone and aggregates and marble. So yeah, that's where we are. That's who we are. I'm chairman. Sean, my son, is CEO. I'm a mining engineer. You can read the documents online. I'm not sure whether you have access to this, but I've been 50 years in mining, worked most places in some method or other, either as a consultant, as an employee, as a developer, and so I've seen most things, but I've never quite got as deeply into the direct exploration as we have in the last 2.5 years of looking at this license. Sean is an environmental scientist, a marine and freshwater biologist. So he is administratively very strong and looks after all of the governance and environmental issues that we're doing. And we've got a great team of board advisors, Christine Blackmore, who's the IOM president, Don Hunter, who looks after risk matters with us, Mark Davis, all the geological type stuff, and Ed Horn, who's a chemical engineer. Plus, there's a great suite of process advisors that I'd like to mention. Paul, who's on the call, Eduardo Candela and Rian van der Merwe, who've been with us for the last 6 years, looking at the different options we have to process the ore that we see. Where is Oman? Well, Oman is sort of on the end of the Arabian Peninsula. Iran is just across the water, and we abut Saudi Arabia and UAE. So really, Oman is isolated from most of the turmoil in the Middle East. It is particularly Anglophobic, and it's quite a very secure and pleasant place to be. It has got quite a good character that most things are ultimately doable by negotiation. So the laws are generally well laid out, but often good for both sides is things can slide, things can change and be repurposed as you go. But ultimately everything's negotiable. Our team that I've described to you, plus some of the guys we've got on site, all have a lot of in-country experience here, and direct mining experience in either mining, geology, and or metallurgy. We had spent since 2015 in Oman actually building a new antimony factory, which we handed over at the end of 2018 to new management, which left us looking for something to do, and we thought that northern Oman was a particularly good environment with a relatively low level of exploration and some of the best exposed geology anywhere on the planet. So we started looking for different things, but we very quickly were focused by COVID on things that we'd actually already got into the portfolio. So we had to do two things. One is we made an application to get a project by a direct approach to the government. At the same time, we spent a considerable amount of time and effort with the government trying to bend their legislative process to allow a much more internationally normal set of standards in the work and the licensing of mineral deposits. And they are not quite as mature as Saudi, but they still desire to maybe catch up with Saudi in terms of the amount of activity going on and the amount of involvement by international companies. So we all have put a team together plus consultants and the as far as we can see, the best industry professionals to look at this particular deposit, and I'll explain some of the challenges we've had over the last few years. So just generally, in looking at the map, you've got Iran on one side that is one on the upper side of a very large subduction zone, and the Zagros Mountains, and you've got copper porphyries, and you've got gold, you've got zinc, you've got all sorts of things. On the other side, you've got Saudi Arabia with a very large area of the crystalline basement and very old Proterozoic rocks. Again, gold, base metals, all sorts of good stuff. So, but Oman sits on the, let's say, on a big, predominantly the bulk of the Oman geology consists of fairly new, big basins, which gave rise to its oil and gas deposits. But around the rim of the country in the north is a very large slab of ophiolite, of ultramafics from a ocean environment that have been abducted on top of the Arabian Shield and are fully exposed on surface. Then down the east coast, there is probably 50 or 60 intrusive or volcanic deposits that still need looking at, many of them with possibilities for some sort of commercial development. Historic mining in Oman has probably been there since 5,000 BC, when copper was mined on a typically very small scale for the time, or for the time it was very large, but in modern production it's very small. But Oman in recent times, since the advent of New Oman with the succession of Sultan Qaboos to the throne in the 1970s, they have tried several ways of licensing the ground in Oman. First was to just award large concessions to people to develop. Then they had a second phase where they effectively took millions of small licenses over probable deposits and were dishing these out to everybody who was interested. And now this third phase is a bit of a mixture where they've issued the bulk of the major licenses to a state company to develop with partners. So it's always looking for partners, and us. And I think we are one of 2 or 3 licenses held privately outside the state companies. I think we got ours because we had come in early with our unsolicited bid, and we'd demonstrated a technical awareness that doesn't exist here in the minerals industry. And the others have both gone, I think both of them are in phosphates, which really by deep drilling and solution mining, I think they're related to oil technologies that they're comfortable with. So in 2023, when we got the call from the ministry to come and sign the concession, we were the first concession issued in 30 years, and we are the first company with 100% foreign ownership, i.e. Knights Bay owns 100% of the concession. There is currently no government involvement, although there is a buy-in once one submits a feasibility study for consideration to the government. What's going on in Oman? It's got absolutely fabulous high quality infrastructure, roads, city development, tech, communications. So we have a very remote mountain range where we're looking at our project, and we can drive on tar within 5 k's of almost anywhere, but that 5 k's is certainly still very, very challenging. I mentioned in my slide here, there are 3 major external players, Rio Tinto, who have a 20% holding in Sohar Aluminium. Vale have a 2 million ton a month pelletizing plant, pelletizing fines, iron ore fines coming from Brazil, and they're developing some new hubs for upgrading iron ore fines with the Chinese company Jinan. And Jindal Shadid is making steel products from DRI in Sohar, and there are many other players of quite large capacity in Oman, most of them using the large free zones that have been established here so that they don't pay tax or duty on transfer of personnel and products in and out of the country. Good electricity, all the energy is based on oil and gas. So natural gas and oil drive the water desalination, and it drives electricity generation. So everything is still dependent on that. But more and more, the government is investing strongly into solar and hydrogen. They're going to look at hydrogen technology and use the solar capacity that the country has to drive this. It's going to be interesting to see how it goes. Shell built a dedicated solar plant for El Taman chrome smelter about 4 or 5 years ago. So 35 megawatts of electricity is running a chrome smelter. It operates just during the day, cropping off the high daily tariff that occurs from the other electricity generation, and they end up with electricity about 15 to 20% below the norm. So that looks like a good way, and I think this is something we can build on for our own project. A potted history of the northern of Oman. Oman, I'm not sure, can you see my cursor? So the bulk of the country, this is a very, very large sedimentary basin hosting oil and gas. This northern band is where we are, and you can see the Arabian Shield on the west, and of course across the water is Iran. Oman's northern shore is covered by limestones and a very big slab of the ocean floor in red, the Samael ophiolite, and this is a 7 or 8 kilometer thick ultramafic Hartsbergite gabbro ultramafic, which has been abducted, pushed on top of the continental shelf, and now forms a range of mountains. And there are copper deposits that were formed in the ocean floor during the spreading, and they scattered through, plus chrome deposits that are pretty high in iron, therefore not the best of chromites there, and relatively small production. Our deposit sits in this little square in the southeast, and we will talk to that a bit more, but effectively it's a limestone slab sitting on top of the ophiolite, and this limestone cap has protected a lateritic sediment that was emplaced probably something like 60 million years ago. Here's a view from one of the mountain ranges across the site. Our concession pretty much is as much as you can see in this picture. We have this black ultramafic underneath. We have the limestones on top, and around the base of this limestone we have the laterites, which are very dark brown. Some differences and changes in facies over it, but we've about 250 square kilometers of material that we are looking at. So this is a long-term exploration project. There are some grandfather projects there where they're mining this laterite to put iron units into cement plants, but this is more and more uneconomic because the cement plants are now getting free supply of steel slags and recycled sandblasting material, which is also slags, for recycling, and they get that for free. Within this 250 square kilometer area, we've got this sediment, this lateritic sediment, and it is between 20 and 80 meters thick, and is outcropping for 135 kilometers that we can see. It's not actually visible, all of it, because there's a lot of debris cover, but so far everything we've anticipated and drilled, we have achieved the the grades and the thicknesses we have anticipated. So neither good nor bad, but exactly as predicted. So 1 to 1.3% nickel, 500 ppm cobalt, 1.5 to 3.5% chromium, and 35 to 50% iron. Back to the infrastructure within from our block. We're just north of the town of Ibra, which is about 300,000 people. We're about an hour and a half's drive from Muscat, the capital, with the airport. Sohar port is 400 k's to the north. Sur is about 100 kilometers to the east. And Duqm to the south is about 440 kilometers. So our infrastructure will more than likely be centered on Sur to place some of our facilities there where there's already adequate water and electricity supplies to build a plant in the next 2 to 3 years. I think all the rest of it is pretty normal. Here's a picture. I love it. Chari Karalat is a Turkish driller who's worked with us for the last 2 years, geotechnical specialist. And we were having a walk around the site, and this is one particular exposure of this sediment. So we don't just have 2 to 5 meters of chemical sediment. This is chemical soils that we're trying to exploit. This is very thick. This is about a 10, 12 meter section of a face that is about 1.2 kilometers long in itself. And all of this, we've drilled 4 holes at the back of it, and all the grades were pretty much as expected. Our grand plan is to, just skipping ahead. Our grand plan is to start, let's say, a world-class nickel operation, which we see as being mining about 10 million tons a year at grades of 1.05, which is our average, to 1.2, and then that will also then produce about 150,000 tons of chromium and about 5,000 tons of cobalt, plus about 4 million tons of iron in iron ore that can be sold over the fence. This was a photo taken when we were awarded the Royal Decree by Sultan Haytham, and this was a major step, I think, in reducing the political risk or the jurisdictional risk of the award. Several things on that is the license is secure. It is like an act of parliament, so cannot be taken away lightly at all. So we have a good fight to secure this and the investors that follow us. Just a summary, the limestone area that we're investigating with the laterites underneath is this funny shape in the middle here. It's surrounded by the ultramafic, the gabbros and Harzbergites. We have 3 major areas we talk about: Shana, which is a small village in this top lozenge; Saka, which is this eye in the middle, which effectively we're not doing anything in the eye itself, but we're looking at the outcrops each side of it; and East Ibra is this area on the side. There are 2 mines in this brown patch in the middle. These are still operating, supplying cement factories, but we're more concerned with mining these and recovering the nickel. And just some statistics on the side here. We've got about 1,400 square kilometers, of which the total area of this outcrop is about 300 square kilometers. The area of interest is a bit smaller. There are several areas that we're probably not going to get to. We've made allowances for geological losses. We think we're going to be able to mine about 102 square kilometers eventually. The thickness average is 22. The thickness of everything we've actually drilled so far is actually now up at 27. So we're a bit ahead on the thickness. It might just be that our current drilling, we're looking at the good stuff, so it's a bit better than the forecast. The nickel grade has been absolutely spot on one all the time since we did a bulk sample of 150,000 tons in 2020 to justify the investment. And we think there's about 4 billion cubic meters of the laterite ore, and the bulk density is somewhere around 2.75 to 4, which gives us something like 11 billion tons of material, and the numbers at almost any price are huge. And the cost of removing the limestone cap falls, I mean, it's insignificant with the effective value of the resources that may come out of here. Just for the geologists present, apologies to Mark, I think I've sent this to you, but this is our current view of what we think this key succession is. The yellow lines denominate the mineralized area. So we have limestone on the top, we have this Kala deposit in the middle, and the Kala is black shales, some green marls and some conglomerates to the east side, and they cap this laterite deposit that ranges from brown to red, from black to brown. The black is very dense crystalline rock. The brown is more typically powdery type material, as in the photograph previously, but they both have exactly the same chemical signature, the same grades, and I think currently that possibly these brown laterites are really just the result of weathering of the black stuff, which we're likely to find in greater quantities ultimately under the limestone. So, and then underneath the sediment, we've got residual saprolites based on weathering of the ultramafic underneath, which is either gabbro or it's Hartsbergite. And then this light blue saprolite is quite often mineralized well into it with good grades, probably 1.2, 1.3 nickel. And there are certain little bands of external sediment scattered through the deposits. And I think one of our best results was one of these thin bands gave us a result of 0.4% cobalt, and we're still trying to ascertain exactly where that came from and how it happened, but it obviously was a surprise on the good side. Just a very quick recap of how we think it got there in the grand scheme of things. In time, from the Cretaceous through to the current time, 90 million years ago to about 70 million years ago, the ophiolite was abducted, pushed over the surface. So it's a compression, during which time it was laterized. The Kala was then emplaced in a depression, i.e. the abducted ultramafic broke the water level and started to weather. You had the development of laterites, and these laterites were subsequently eroded into a particular depression, during which there have been three major phases of extensional deformation of the crust, with typical normal faulting in Horsten-Graben formations, where we've got thickening of this sediment where the faulting is. So some of the faulting movement was concurrent with the deposition. You then had a long period during the Paleocene and Eocene of where the limestone and marl cap was put on, since when it has then weathered during another period of extension for the last about 40 million years. So that's what started it. Here's a typical picture of some of the outcrops where this dark rock has been weathered. We have a facility, a camp, where the drillers are currently staying, and a core handling and management facility where we cut the samples for assay. The active mines on the property can give you some idea of the scale of this thing. So this mine is NMT. It's situated at East Ibra, and you can see here it's about 25 meters of laterite, and it's 1.5 meter. The open pit is 1.5 meters long. This is Desert Industries, about 30 meters of thickness, and it's a U-shaped pit that's about 800 meters long. There's another little mine on East Ibra where they've stockpiled about 250,000 tons of material, but they haven't been able to establish a profitable contract to sell it. So we have signed up some of these mines to take their ore, all of which is at these grades I'm talking about, and the idea is to, as quickly as possible, treat that through our plant. Here's another picture of NMT showing during its operations. It's a red friable material, and it's a rock. It's not a lateritic wet material. It's a dry rock at 2-3% moisture, and generally this 20 to 50 meter thickness estimate has been demonstrated almost everywhere we've looked. The difference is, though, we have, in the last 6 or 7 months, we've undertaken a program of 32 boreholes in what we call Saka Central, and you can see the material here. The magnetic sediment, or the sediment here, is black. It's highly magnetic. It was termed magnetite by the locals, but again, the chemistry says this black rock is magnetic, and it is the same chemical signature as the laterites we're seeing in the previous picture, which is brown and non-magnetic. All of this material is also capped by 15 to 20 meters of weathered material. Again, it's the piezolytic laterite type material, same grades, and we are drilling holes here. We've drilled now 16 of the 30 holes, and we hope to get most of it finished by the end of the year. So this area in the middle of this picture, this is the picture where the magnetic material is. We plan to finish that this year. We'd hope to do another area with very good grades and materials at Shanna West here. Oops. Shanna West, but we've been so concentrating on the things going on here and the test work, we haven't got started yet. And we'd hope to also drill 2 other big areas here. We've laid the holes out, and we will probably get into that next year now. In addition to the laterite here, there's a major shear zone running through the laterite complex here that is hosting copper mineralization that we're looking at in joint venture, and the whole of the ultramafic basement around the limestones is also a host for chromite, and we're also looking at that in joint venture. So far we've drilled 7 holes last year. We took 233 samples. We then took 88 samples in February of this year. We took 9 metallurgical samples sent to Indonesia for testing. I'll get onto that in a moment. We've now finished 16 diamond drill boreholes in Saka Central. We've got 96 sample results. We got another 100 yesterday, which I haven't added and updated this. So there's still 350 samples bagged and tagged, ready for sampling. And these figures at the bottom show you the XRF and the ICP weighted averages of what we're getting. So we had 588 samples, 35% iron or 36% iron. The chromium 2.3, 2.14, nickel 1.01, 1.03, and the cumulative width of the XRF material was, i.e. above 0.7 nickel, was 290 meters, and the over, can't remember how many holes that was now, so that's 23 holes. So the sample zones are, no, it can't be right. So anyway, the sampling we've done so far is giving us about 25, 27 meters thickness average for the holes we've drilled. But the grades we're looking at are really good, and the cobalt is still in that 530, 550 range. Some site visit. This is the magnetite area as we just looked at. There's a wadi running through it, and it's very clear that this was a sloping ore body through here, and the wadis have cut through it. So this black material is what we're assessing over about a 2-kilometer strike and about 1.5 kilometers deep. We've got 2 rigs operating. Picture of one of the mines that's still working, and the complete contrast of material. Whoops. This box is the material we're drilling now, the black material, and you can see here that the open pits near the outcrop is quite highly weathered and looks more like a brown, which is probably why it was described as a laterite in the past. At the end of last year, we assessed all of the drilling that we had done, plus the profiles that were measured, and we came to this assessment using the standard format of NI 43101 or the CEng guidelines on this. We used 50-meter radius for measured, we used 100-meter radius for indicated, and we used 250 meters for inferred, and that gives us something like 100 million tons at 1.03%, 521 cobalt. The chrome grade I haven't got here, but it's probably about 2.5 to 3 for this material, and the iron is going to be 35 to 40%. The global target that we're currently looking at is probably, we'd like to see in the next 3 or 4 years of the second phase of exploration that we push up the inferred resources from where they are now. We want to move all this material into the measured, indicated and inferred grades, but we've got about 6 billion tons that is insight from sampling, from projections, from measurements and outcrops, but it is nowhere near a proper resource. But we're trying to keep people advised that the target is a much bigger resource, but we're in very early days. The XRD work that we've looked at, we have a whole soup of different minerals, all typical laterite minerals, and all the different suite of iron minerals. And this has led to a lot of cul-de-sacs of investigations, because we were trying to see what industry standards were for laterites, and it doesn't really apply other than the mineralization is very much laterite, but the rock and the formation is nothing like it. Looking at comparison with nickel-laterite mines, this is our property, and it's probably the top 3/4 of the deposit over here that we're looking at. That's 5 kilometers. And this is Ambatovi in Madagascar, but in the same scale with a 5-kilometer bar. And this is Goro in New Caledonia. Both of those have built plants capable of producing 60,000 tons of nickel, and they've had very well publicized problems with the HPAL technology of development. And I lead that into, because I just want to spend a little time talking about what our grand plan is. Test work, we started doing test work by drilling and doing some metallurgical evaluations of the work over the last 2 years. We're currently upping the drilling. We've got 2 rigs operating. They're not particularly efficient, but the ground is very, very poor, and the overall turnaround time of samples is appallingly slow. It will improve with UIL, a new company that has just reopened the SGS lab in Sohar. So we think that turnaround times and everything will improve during 2026. By next year, by the middle to the end of next year, by the 3rd quarter next year, we want to submit a feasibility study on a 300,000 ton a year plant to treat the laterite to produce 2,700 tons of nickel, 150 tons of cobalt, and 5,000 tons of chromium metal, and about 100,000 tons of iron ore. And we think that this demonstration plant will be a direct leach plant, which is not what we originally started to do. And there's a reason for that, but we need to develop a concentration process that we've already got a lot of work done for, that we've done quite a lot of modeling of, and but we think that that's not going to be quite ready for a feasibility study by the end of next year, because we need to build a purpose-built pilot plant and do a lot of more work. We've looked at different options of the commercial plant, and of course it depends on the nickel price, it depends on a whole number of things, and we think that that decision will be made now, construction in 2029 for a commercial plant. And my personal opinion is we'll probably be going for a 33,000 tons a year of nickel, about 3.3 million ton, a module of a full-scale plant of 3 modules. So we'll build the first module and get it up and running by sort of 2032, 2034. So there's a grand plan that we try and do this, and the expected life of one of these is probably over 100 years with the amount of ore available at the typical 1% grade. Site characteristics, we're in the regional governorate of Ash-Shakir, and so the governor controls all aspects of life in this area, and the ministries then provide him with services. The weather is hot and dry. Today it was a glorious sort of 28 degrees, hot and sunny. We get rain approximately twice a year with thunderstorms. We still have a lot of hydrological studies to do, because all of the water reservoirs are in the wadi rock. So if we're looking at this picture behind the camel, the wadi tends to be an area of conglomerate or loose rocky material in the bottom of the wadis, and the water sits on the bedrock in this open material. There is no water in the rock. All of our boreholes are absolutely dry. The rock moisture content is probably 2 to 3, and even inherent moisture combined with the various minerals that are in there is low at something like 6 to 8%. Oman has the highest solar energy on the planet at 55 kilowatts per square meter per day, and we have an arrangement with Shell, who did, as I mentioned earlier, we have an arrangement with Shell to provide us with the solar farms and all the rest of it as part of our funding program. Water is all pretty much, we don't want to abstract too much water from the system. So we're looking for dry processing on site and wet processing where there's adequate desalination water. And we've registered a block for building the plant in the port of Suez, which is currently doing a major planning exercise to develop it as an industrial port. Our grand plan for energy storage, we think the very, very simplest is pump water storage. As you can see from this picture, there's some super relief on the property, and in fact about 10 to 20 kilometers away there's an escarpment of over 1,500 meters, which means that we can establish a pump storage system, and we can put any amount of solar energy in, and we'll come back to what our grand plan for the legacy is of the mining project. It involves quite a lot of use of the land for combined agricultural and solar energy usage. And we think the agricultural usage of our legacy areas can achieve quite high bio-use by using biomass for producing fuels, and also producing materials that have a good cash incentive for the local populace. Our demonstration plant, we've had a plant scoped out in Indonesia. It has already been designed for an Indonesian ore, and they're currently doing a workover to balance it with what we want. And the material is to leach the ore and then to separate out the nickel, cobalt, chrome and iron, and the nickel cobalt will be in an MHP, a mixed hydroxide precipitate, and cobalt, chromium will be metal, and iron will come out as an iron oxide. The process is very simply, this is how the test work has been going. The ore was ground, assayed. There's a dosing system adding concentrated sulfuric acid. It's then roasted at 650 degrees for about an hour. It's then leached with water, and then you have a separation, and then you have a nickel and cobalt rich PLS, and then we've got the recoveries, which I'll mention in a moment, and then it's a question of precipitating that material and ending up with a residue. So we're going to expand on this. This is our natural refining section, and the idea is we will modify this for the design of our plant so that we can repurpose it as, first to start it as a demonstration plant, but then to use it as the refinery section of a plant that's about 10 times bigger. The results of the direct leaching were surprisingly good. Everything was over 80%. Most of it was between 90 and 95%. One sample was down at 40, and that was one of these crystalline black magnetic ores. And our take on that is that the crystalline nature of it stop the acid getting to the metal, or we didn't have enough acid to actually break up the bonding. And it also could be that there was excess carbonate in there which neutralized the acids. So that we're doing additional test work now to see if we can get that up. But at the moment, our demonstration plant will be operating on the 8 samples that we sent them, which are all from the little producing mines who can produce the ore tomorrow. And the idea is to design the plant and start operating at high efficiency to produce nickel cobalt by this method, and then expand on it organically as we understand the front end concentration of the material better. Our legacy, we're already thinking about legacy, even though we haven't actually started, but the idea is to take all the limestone to build very large paddocks, and this is the section through it, and then you take all this laterite sediment, which is very fine clays, silicates, iron ores, and anything that is waste or not going to be treated can be then put into paddocks. We would also include any recycled materials from our plants, and this will be built into paddocks with nutrients to make it agricultural. So these are areas that the limestone will be repurposed. We will have infrastructure, roads, electricity, housing, and then the paddocks will be the agricultural areas. So almost all the people will go from living in little cluster homes of 600 square meters, will have quite large agricultural holdings, and they will be able to have a permanent, sustainable future of being able to produce biomass, palms, agave, all sorts of things that we're looking at the moment. Here's some pictures of typical things that we do. So you have solar farms with agriculture underneath to use the solar farms as shading, growing agave, which is pretty much suited to the climate here, sisal, aloe vera, and blue agave if one's of a particular persuasion. And we think this will work. We're talking to the Ministry of Agriculture plus the governor, and the idea is that the mining will be super long, it'll be multi-generational, but obviously at the end the sustainable legacy will be farming. Oops. So just for those who don't know, currently nickel is 14,800, which is pretty much the cash cost of HPAL. Our grade is 1.5, which gives us about $140 a ton of net. I think I used a 90% factor here to look at extraction, and so you're looking at about $140 of revenue per ton. Cobalt has bounced back from, it was about 30,000 earlier this year. It's bounced back, still a contribution, $25 a ton. Chromium is a new boy. Its prices to the US of chromium metal is about $10,000 a ton. It's got good grades of 2.15 average, another $200 a ton. And the iron ore, ordinary hematite, 62%, is $97. Our grade is 35% iron, and that would give us probably somewhere around $28 a ton ultimately of revenue from selling the bulk of our waste. So we're going to end up with probably only about 30% of the mined mass as waste. The market, as I said just now, here's the cost curve, and pretty much all of the HPAL stuff, which is MSP, MHP, all of these, their cost, this is the $14,000 line cuts through right through the middle here. So most of these have already closed. All of the high-end things in Western Australia have stopped. And most of the mines now are just washing money because they're pretty much at cut-off grade costs. And the way we think we can avoid this is to change the attitude and actually make sure that all the byproducts that can be gleaned from the material is used. And we think there we would probably be able to drop our cash cost to $8,000, which will probably put us probably at the top end of the first quartile. And we're pretty comfortable in that scenario. So we looked at risk, jurisdiction, we've got covered by the Royal Decree. We think we've got an enormous resource. We've just got to prove it to everybody. And all of the issues that we've said, which is a complicated metallurgy industry, large production of metals, is all within the request for Oman's Vision 2040, which are the major objectives of the country, in-country value. And we think that the extraction results that we've got have proved that this stuff extracts actually very easily. We obviously have one area that we really need to drill into with additional metallurgical testing. We're currently mobilizing a 25-ton sample to run some pilot plant scale tests in Indonesia, and they should be complete by the first quarter next year. How does the UK benefit from this project? We've got super support from the embassy here, from the ambassador down. We've got very good relationships with DTI in London. We haven't looked to use the UK for funding, but what we have done is look at the original request where we got into Oman was the government mining engineer at DTI at the time said the UK needs 150,000 tons of nickel to support its industry. And Britvolt crashed because it didn't have a secure supply. And we can provide that from here. There is a bilateral agreement with the UK. There are no charges on transference of material from Oman either way. And so there's no duties and there's no taxation, although income tax is likely to be applied to everybody in the coming year. We think the university collaboration is important. This week I've been on site with Mike Searle from Oxford University, and Tom, I know you're listening. It's been a brilliant week of actually talking to geologists who really know their stuff and have helped us immensely. We've just had another geologist here from St Andrews in Scotland with a work experience, and she was brilliant in helping us understand some of the sedimentary geology. And of course, we're changing it all again. And I think one of Tom's little tasks for his tour here is going to be looking at some anomalous sulfide and possible lithium that we found in some of the lateritic assays. And it could quite well be that one hole was showing anomalies, and it could be a lab error, but we're doing work now to demonstrate what it is. And I think the student swaps, certainly Camborne School of Mines, is being requested to engage with Oman universities here because they see the need for skills in the downstream mining and metallurgical areas. I think there's a lot of scope with us and other companies for metallurgical, geological and engineering research and industrial experience when we get going. and I think the UK can maintain its good standing here by properly engaging. I think it's really hard for exploration companies coming here. It takes a lot of time, a lot of discussions over and over again, but I think it is worth seeing it out. But we've got more than enough ground and areas of research to engage with most people. So all of you, thanks for listening to me. That's the story.